Hey, did you know that a cup of hot coffee weighs more than a cup of cold coffee? But we're not just going to talk about coffee. And in an electric car, does it get heavier when the battery is charged? Today we'll use these two great cars, the fully electric BYD Dolphin Plus and the BYD King, a super hybrid. Not to show they're beautiful, economical, modern, you already know that. We'll discuss a topic that appears simple, but actually involves real physics, energy's weight. If we take two identical cups and pour 100 grams of coffee into each of them, they'll have exactly the same mass, right? Next, I take a cup, microwave it, and heat it to about 90 degrees Celsius. If I come back and compare these two cups on the scale, there won't be any difference, but the hot cup is actually heavier. And it's not me saying this, it's Einstein. And this happens because the hot coffee has more energy inside it. Initially, the two masses seem equal, but that's not actually true. Actually, the mass of the coffee is its own mass plus the energy it has inside it. This makes a slight difference, but we can calculate it. Do you know which equation? This one. You've probably seen it on mugs, t-shirts, movies. It's the most famous equation in physics. And it's no wonder. This was a revolution in science because Einstein managed to show that mass is a manifestation of energy. Mass is a form of energy. This means that all mass already carries a huge amount of energy just by existing. All stored energy, like in a hot cup, appears as mass, even if it's very small. Of course, in everyday life, scientists aren't going to use this formula to calculate the difference in mass between two cups of coffee. It's used to understand how energy can be transformed into light, heat, and motion. This happens in the processes of nuclear reactions in the sun, in supernova explosions, in particle accelerators, and in nuclear power plants here on Earth. But since none of us here work in a high-tech laboratory, let's use this formula to calculate how much heavier this cup is. The E here stands for energy, the M stands for mass, and the C is the speed of light, which in this case is squared. Including the speed of light in the formula gives the odd impression that you need something moving extremely fast to use it. It has to be at the speed of light. It's not like that. It's just a number used in the equation, and here the speed of light squared equals 90 quadrillion. It's a 9 followed by 16 zeros. For calculations, this is bad, okay? So in practice, we do 9 times 10 to the 16th power. This 10 to the 16th means these 16 zeros here. So, all right, we already have this number here, that's it. Now we need to calculate the energy that was used to heat the cup of coffee from about 20 degrees Celsius to 90. I'm going to use another formula from chemistry called the sensible heat equation. If you want, you can look up how it works later, but the result of this equation will come out in joules, which is a unit of energy. What I'm going to use here is the mass of the coffee, the specific heat of water, which is how much energy it needs to heat up and how much it was heated. The final result will be 30,000 joules. But since I'm using powers of 10, let's write here 3 times 10 to the 4th, that is 3 with 4 zeros in front. Look how simple it is now. I already have this number, which is 3 times 10 to the 4th. The mass is what I want to find out. I still don't have it. And this here is that bizarre number, 9 times 10 to the 16th. I move this number over here. Doing the math, the extra mass that the cup has is 0.3 times 10 to the minus 9 grams, or 0.3 nanograms. Let's write this number in grams. Let's understand exactly what it is, because it's very small. It's this, 0.000003 grams or 0.3 nanograms. Honestly, I don't know if there's any scale in the world capable of detecting this difference in a cup of coffee. But I know at the beginning of the video you showed that scale showing a difference, that old scale you bought at the auction, so you tricked me. It's not always like that, but sometimes this guy is right, because in this case I needed to make that scene at the beginning. So I put a nut inside the hotter cup, but it was just for illustration, it's just to start the video, right? What matters is that the hot cup does have a different mass, which has several implications, including for batteries. For example, when you turn on a flashlight and walk, the battery drains. It loses energy and the flashlight gets lighter and lighter in your hand. Of course, you won't be able to feel it, but it does get lighter. A battery? But what about the battery of an electric car, which is much bigger? Exactly, the same occurs with an electric car's battery. Today we have two great BYD cars to demonstrate this. One is the fully electric Dolphin Plus. It has a 60.5 kilowatt-hour battery and accelerates from 0 to 100 in about 7 seconds. And the other one is the BYD King. It's a super plug-in hybrid, which means you can drive it in electric mode. The combustion engine charges the battery, but it can also extend the range when needed. Plus, you can charge it with a power outlet. Look at this. We visited one of BYD's headquarters in Campinas, where they have the hybrid car setup. We can see the engine in the front and underneath, here in the car's floor, right in the center of gravity to keep it close to the ground and make the car much more stable. There's the battery, which is fully integrated into the structure. And it's not just any battery, it's the Blade battery developed by BYD itself. They set aside some used batteries here for us so we can get a sense of their size. So this one here is from the Dolphin. It's bigger because it's from a fully electric car. Just so you have an idea, it weighs 330 kilos. This one is from the Song and is already a bit smaller. These batteries are denser than most other electric car batteries. That means that per kilogram it can store much more energy, which in the end will mean more range. Besides that, they're also very safe, going through several extreme tests like nail, fire, and drop tests, and they still hold up strong. They can handle more than 5,000 recharge cycles, which means the battery lasts a long time. Yeah, we can't see it from here, but there's a rigid structure inside, kind of like a honeycomb, that helps make the whole battery shell much more rigid. It's part of the car's structure. And one cool thing that we only get to see with the battery open like this are these little tubes for cooling. It's like this is the freezer in your house. These are air conditioning ducts to keep the battery always cooled, which will make it more efficient and last much longer. Why is the hybrid's battery smaller? Take this car, the BYD King. It's a super hybrid. It has both an electric motor and a combustion engine and can run on either. It always prefers running on electric. There's a button on the console that lets it run fully electric when pressed. But if you need to charge the battery or need a bit more power, then yes, it turns on the combustion engine. Since this partnership between the two types of engines is really well balanced, if the tank is full and the battery is at 100%, this car has a range of 1,200 kilometers. You could travel from São Paulo to Brasilia and still have about 200 kilometers remaining. To charge it, it's simple. If you're at home, you can use a regular outlet, even a 220 volt one. It will take a few hours, but you plug it in at night and in the morning the car is already charged. You can also install a wall box like this one at your house. Then the charging is much faster, and if you're out on the street, you can use a charging station with a fast charger. For reference, in 30 minutes the battery can go from 30% to 80% charged. But in practice, what really happens when we charge a battery like this, and how many grams do you think it gains when it's full? I'll make an analogy here. I'll try to explain using dominoes. When the energy arrives, it starts to force a series of chemical reactions. It's as if it starts tidying up the house, reorganizing the molecules in a way that the battery starts storing energy again. In the end, you convert grid electrical energy into chemical energy stored in the battery. And as you accelerate the car, you start using up that energy, you start disorganizing the molecules inside again. And that's where Einstein's equation comes in again. That chemical energy stored in the battery has mass. Now that we understand, it's easy to calculate. The Dolphin Plus's battery has a capacity of 60.5 kilowatt hours. What does that mean? It means you can draw from it 60.5 thousand watts for 1 hour. Yes, it's an absurd capacity. It's like having 12 showers running at the same time for an hour. The issue is that Einstein's equation uses energy in joules, not kilowatt hours. The good news is a joule equals a watt second. It's easy to convert. Kilo means 1,000, so multiply by 1,000 or 10 to the third. 1 hour equals 3,600 seconds, so multiply by 3,600. 3.6 times 10 to the third times 10 to the third equals 10 to the sixth. Multiply 3.6 by 60.5 on the calculator to get 217.8. Move the decimal and round. It gives 2.2 times 10 to the 8th because I moved the decimal point and increased by 2 here. This is the number we're going to use in place of E in Einstein's equation. I'll plug the numbers in here. We have the energy, we have the speed of light squared, we need to find the mass. This is a simple equation, okay? If you're finishing high school, this is something that just by looking at it, you should already understand how it works. Even I forget sometimes, but returning here helps me remember. So look, the extra mass that the BYD Dolphin Plus has when it's charged is 2.4 micrograms. Converting that to a number that's a bit easier to understand, it's 0.000024 grams. It's a much bigger number than the energy of the cup of coffee, but even so, it's absurdly small. It's very hard to have a scale that can measure the weight of a car and still register that many decimal places after the zero. If a flea jumps into the car, it's heavier than that. So in the end, energy does have weight, but with good technology, that energy will turn into range, performance, and safety. And the most amazing thing is that physics concepts that seem distant from us are actually at the heart of the technological decisions in a modern car. From a cup of coffee's mass to a BYD battery, everything is both energy and mass.